Lucas.
No, I took a lot of
Okay, well,
just weeping in the background.
Have you taken bio yet?
No, that's the most of the intro bio classes I'll together next week.
Wow. The bio here is like
The devil.
the devil.
well, it depends who's your professor.
There's only one professor. Literally, it's like Super Mario. You don't pass that shit. It's like, you're never getting to browser.
Okay, so I don't particularly want to be here longer than I have to be here, so I'm just gonna go through it. You guys tell me if you have questions.
Please.
So yeah. So yeah, your plan's gonna be pretty close to this. I'm just gonna go through change functions and do some others. Very, very minor. So one is just how I gave you a bunch of derivatives to do. So let's just go into them. So A was y is equal to x times the cube ln x. Here, the way I did it, rewrite that, and just do the product rule. Derivative this times that, plus you leave this, take the derivative of that, which use the chain rule. This x plus this out. No.
The point, you just copy it down before you just continue, so we're all on the same page.
Yep, sure. Yeah. So I just rewrote the radical as a power and did the product rule. And when I'm differentiating this part, I had to do the chain rule.
What happened to the x?
I got the chain rule from this gave me 1 over x. That x canceled the x in the front.
Which two cancel?
This x in the bottom canceled that x.
I had you wrong, one question.
Yeah.
I'll leave it like, when you got y prime at, and I leave it like that, how many points is that?
Well, for this section, it'd be 4 or 5 points each. I'll write out 1 point.
Okay. 4 or 5.
Okay. So for this one, I just jump into it. No need to rewrite. I use the quotient rule. So it's the bottom times the derivative of the top. Derivative of the top being the product rule. So it's e to the x plus x e to the x minus the top times the derivative of the bottom, which you need the chain rule. All over the bottom squared. At that point, x plus 1 is a common term. I can factor that out. I'd be left with x plus 1 times e to the x plus x e to the x minus x 2x e to the x. This cancels that. Probably I feel like this would be killed over here, so I'm going to multiply this out. X e to the x plus x squared e to the x plus e to the x plus x e to the x minus 2x e to the x. And so, no, not that. This and this kills that. And so I just have x squared plus 1 e to the x. So again, you do the quotient rule. So it's bottom time derivative of top minus the top time derivative of the bottom. For this one, I had to use the product rule, so I differentiate the x, which is a 1, and I left the e to the x, plus I leave the x, differentiate e to the x as itself. And then the derivative of the bottom is a chain rule, bring the 2 down, the power becomes a 1, you multiply by the inside, which is just a 1, and so just like that.
And on the bottom, you factor out the e to the x on the last line.
Here? Yes.
Yeah.
So I have x squared e to the x plus 1 e to the x.
Mhm.
I just factor that in.
Factor it, okay.
Which, if you left it as x squared e to the x plus e to the x, that would be fine.
Did you distribute the x plus 1 on the third line?
Yeah, I multiply it out. So x times this, x times that, then 1 times this, 1 times that.
Okay.
That gave me this. Okay, so here I rewrite this as a power, and it becomes the product rule. So I differentiate this, leave this alone, plus leave this guy, differentiate that, leave the chain rule. I factor out common terms, so I can take out like an x minus the half e to the x plus ln x.
What happened to the final one
Multiply out. The 1 over x kills the x.
Got it.
So would you first break this up into like an ln of something minus another ln?
Yep, I break this up. Once you have that ln in the front, it's much easier to do that. So this is ln of x to the x minus ln of x minus ln of x plus 1
Oh.
minus ln of x minus 7.
So you had an ln of a whole bottom.
Yeah, but even the whole bottom, it's a product, so you can multiply that up.
So don't you add?
Yeah, I was gonna say, wouldn't it be like
ln
ln
to
of x
add
plus ln of...
It's minus, and in brackets you expand with pluses, so that the negatives distribute.
It's
Oh, that makes
minus.
sense. Yeah, that makes sense. You skip this step.
No,
Yeah.
wait. What did you?
So it's all negative because...
You could have
Yeah.
you could have written this, but then once you have a subtraction and you do several terms, you need parentheses.
Right.
That's ln x plus ln of x plus 1 plus ln of x minus 7. And then this negative sign
Distributes into all...
makes everyone negative. So that just becomes, the powers I can bring down, that's x ln x minus ln x minus 3 ln x plus 1 minus ln x minus 7. And then after that, your derivatives is no big deal. This here's a little product rule, so you differentiate x, leave the ln, plus you leave the x, differentiate the ln. These x's will cancel. Minus 1 over x, minus 3 over x plus 1, minus 1 over x minus 7. So most of that problem was the algebra, the derivative part was just doing those. So this guy here, I just write as a 1.
Wait, so why did you put ln with both of those things? On the first time?
Where?
The first one.
First
What
one.
about the first one?
Yeah, why did you put ln on both of them? Why are we not doing the product rule?
It's a property of.
The quotient rule.
It's a rule of logs. Once
It's a
something.
rule of log. If you have ln of something divided by something, it's that.
Okay.
That's a rule that we have. If you have ln of something times something, that's a sum.
Okay.
And if you have ln of something to a power, that's just a power times ln of the thing. So from here, I use the top rule to get here. And then for this, to break it into these pluses, I use this rule. And then distribute negative signs, and then to get this x down in front, and that cube down in front, I use this rule. Okay, that was problem 1. Moving on to problem 2. I multiply at the top, x3 minus 3x plus x squared minus 3. Divide x into each term. So I get x squared minus 3 plus x minus 3 over x. And then it's power rule. So x cubed over 3 minus 3x plus x squared over 2. This guy's the ln. Yes? Just think about it. What?
You erased it. I was still.
Yeah, well, it's on video. Go
Oh.
back and catch it. We're recording. We're recording.
Okay, let me ask you this question.
This exam is like twice as long as normal, so I just want to
Wait,
keep
where's
going.
that? Oh, okay, you went right out.
I just multiply it out. Foil.
Yeah.
Get that, then I divide into each because there's one term in the denominator, get that, and then power rule, ln.
Okay, that's what I did. Okay.
So would you always recommend trying to like factor out everything?
Yes, first thing you try to do, does a basic rule work? If not, can I simplify it to do a basic rule? And that's where we are here. And if not, then you try to use substitution.
Gotcha.
That's always the approach. Part B.
I would use substitution.
Yeah.
For the ln.
Yeah, because the ln, and you see that divided by x here. Yeah. And again, don't let this scare you, because you can just move it out. It's really not a problem. And so here your u equals ln x. Your du would be 1 over x dx, which you have here. And so your x du is equal to dx. And so you go and you plug them in. That 5 over 4 is just there. The ln you change to a u, so that's radical u over x. And your dx becomes x times du. The x is cancelled. And so you just have 5 over 4 times radical u du. That you can use the power rule for. You rewrite it first. So you get u to the 3 halves times 2/3. This cancels to that. And you get 5 over 6 to the 3 halves plus c. Now you replace u with ln x.
Can I have a second? Being feeling?
Yes. Is it quick?
Yeah. Oh, something Hernandez.
This one's
This
easy.
should be easy. Yeah, I thought it was really good.
This one's easy. I got it.
Yeah. Okay.
I don't have that.
You're on
So I have a question about that. In the textbook, whenever there's like an answer like that, they would usually leave it as, let's say, like 5/6 times ln of 3 to the 3/2 times x. Would that still be the same answer, or?
times x.
Yeah. So like the 3 to to the power of the 3/2, they would write ln 3 to the 2x. In the textbook.
Oh, yeah, that's kind of weird to do that with an element. But that would,
Yeah, that's how they usually write it in the textbook.
really? That's a strange way to write it.
Like you get what I'm saying, though, right?
I get what you're saying. They'd write like ln 3/2x.
Yeah.
Yeah.
That's kind of weird. I don't see that very often.
Okay. Because all their answers are like that, and I'm like, I get that, but
Yeah, that's strange. This is fun. It is. It's more typical to do that with trig functions. I've never really seen that with logs really. C, integral of 4/e to the 5x dx. It appears to rewrite it, and it turns out a basic rule applies. The 4 times out, e to the kx is 1/k e to the kx. So minus 4/5 e to the minus 5x. D. So here's we have a definite integral, you have those numbers on it, which means you're going to have to apply the fundamental theorem of calculus at some point. Plug those guys in. So again, it doesn't look like a basic rule, can't really simplify it to look like a basic rule, so I would do a u substitution. The denominator makes it complicated, the du would actually give me that 2x dx. And so my dx is equal to du over 2x. And so now I plug that in. This is x goes from 0 to 1, of 2x over the radical of u times du over 2x. 2x is cancelled. So that gives us 1 over radical of u and u. X goes from 0 to 1. So that's u to the minus 1/2 du, do the power rule, u to the power of a half times 2. And my u is x squared plus 1 to the 1/2. So plug in a 1. So that's 2 radical 2 minus, plug in a 0, and that just becomes 1. So the answer is 2.
Could you explain what happened to the du, please? Just disappeared.
I integrated. I took the antiderivative, so it disappears.
Can you just look up how you got the last one, because I keep getting something different.
Where?
Like how your boxed answer.
Oh, I put the 1 in here. So I just have 2 times 1 squared plus 1 radical minus, I plug in the 0. So I have 2 times 0 squared plus 1 radical. So this is 2 times 2 to the half minus 2 times 1 to the half. 2 to the half is just radical 2. And 1 to the half is just 1. So
Where'd you get the 2 in front of the u from?
See, I can do it 2 times 2 to the 1/2.
Where'd the 2?
power rule.
It should be a 1/2 on the bottom. You just-
You add 1 to the power, divide by a new power. Dividing by half is the same as multiplying by 2.
Oh.
Divide by
okay.
half, you flip and multiply. You get 2.
Okay.
Gotcha.
So it's power rule to go from 2 to 1. last one. Looks pretty scary. Panic. ln3. This is x squared e to the x cubed. X. So now, you notice there's an x cubed and an x squared, but if you differentiate this guy, you get an x squared factor there. So I just do u equals x cubed. My d would be 3x squared dx. That means dx is equal to du over 3x squared. So I plug that in. So x squared times e to the u, and dx becomes du over 3x squared. This kills that. 1/3 times the integral e to the u du. So integral of e to the u is just e to the u. That's e to the x cubed between 1 and the cube root of ln3. Now apply the fundamental theorem, take this, plug it in here, we cube the cube root, disappears, that just becomes ln3 minus e to the plug in 1 in here, you just get e to the 1. Now e to the ln3 is just 3. That's just a third times 3 minus a third times e. That's 1 minus a third.
How did you get the x cubed?
It was there from before. U is x cubed.
Which is why I hate you.
So I get e to the u, what?
That looks hard, but that's why I hate you.
Yeah.
That's why I hate you.
It's all like that, that's what I'm trying to tell you.
What?
That's not all. I ain't gonna say no lie.
That's how it happens. That's how I've had students who would like, they've been pulling deals the whole time, and then it took till the end of the semester for them to realize, wow, it's actually, they actually started looking at it simpler after a while, and they're like, oh.
Why did you get rid of the radical there in the last one?
Because it's a cube.
Yeah, we cancel it.
Oh.
X cubed and I plug in a cube root. Cube kills the cube root.
Oh, got it, got it.
I would help doing that. I just never like that.
And this one is just to simplify, just seeing if you remember your rules for e's and ln's.
Are you putting this video tonight?
Yeah, like, can we get it like right after?
So could you start by L adding both sides?
What?
No.
No, you're just simplifying, so you're not
Like,
solving
You
something.
cancel e
Cancel
and
those
L.
first two. The first E and L.
Be careful, because there's this plus y is in the power of this guy. So the first thing you want to do is realize that that's actually a multiplication. And then this one, realize that this you can move up. Because you want it as e to the ln of something. You don't want anything else around. Right, so that, because there's a plus here, that messes up the rule. And there's a multiplication, something multiplying it, it messes up the rule. You have to get rid of it. So now e and ln cancel, and this guy just becomes e to the x times e to the y. This guy, e and ln cancel, just get x cubed. And you can leave it like that. Or you can undo the rule and just, but either is fine.
But if you just wouldn't you still get that if you don't like multiply in the second step? Wouldn't you still get x plus y out there?
Yeah.
No. Yeah, you won't forget it.
And it's not just x plus y, it's e to the x plus y.
Yeah, I'm saying, yeah, I know that.
And this was just like a derivative one, except we're not differentiating when we're done. We're just simplifying first. So first, realize that this is just all that to the 1/3 power. right? That's what the cube root means. And then the laws of log says I can take that 1/3 and bring it down in front.
Wait, what just happened? I took the decay root and put it in.
Yeah, the cube root is a power, it means a 1/3 power, and then the rule says I can take powers in front.
Okay.
And so now, open bracket, ln of something divided by something is just ln of the top minus ln of the bottom. You write this radical as powers. So whenever you're dealing with e's and ln's or derivatives, you want to rewrite radicals as powers. Because all your rules have powers in them, not radicals. Yeah. So now at ln of a product. Now we know the rule that ln of a product is just the sum of ln's. So it's ln of x plus ln of x minus 1 squared plus ln of e squared minus ln of x to the half minus ln of x equals 1. This negative sign has to distribute. We need to do each of the ln's.
Alright, so what if I look at the step before the
That's like halfway.
Yeah.
You want it to be something as simple as possible. Just ln of something, maybe multiplied by a constant. You don't want any powers all over the place or anything like that.
Okay.
So,
Now you distribute the 1/3.
no, I wouldn't distribute. These powers I'm going to get rid of.
Just,
So it's 2 ln of x minus 1. ln and e will actually cancel. That's just a 2. This is 1/2 ln x. This 3 comes down. 3 ln of x cubed plus 1. And that's fine. Technically you could combine these two, but that's fine.
yeah.
It's easy when you can see things in the basic rules. Like if you see this as just
Yeah.
A and that as B, then it's not so bad. That's the thing. You want those goggles on and then you realize it's not so bad. It's when you look at it and like, oh my god, it's complicated, there's ln's and radicals and your brain starts spazzing up. You know, just think of them as groups. So problem 4, this is a radioactive decay. It says in 3 days a 10-gram sample. So I'm thinking of that as my P naught. So P naught is equal to 10, that's how much I started. Decays to 3 grams, right? So I know that P naught is that, and when time is 3, it's 3. Find the differential equation satisfied by P. So remember the differential equation is just P prime equals minus RP, minus because it's decay. It's getting smaller. It went from 10 to 3, so we have to put a minus here. Right? So now you have to find what that R is. Right? So that's what we're going to do. But we also know that P equals P naught e to the R minus RT. I'm going to just plug in values. So P naught I know is 10. And I know that when time is 3, my remainder is 3. So this gives me 3 over 10 equals e to the minus 3r. How do I solve for r?
ln.
Get ln both sides. This means your r is equal to minus ln over 10 over 3. And so you plug that in.
Wait, I thought the decay was ln2 over whatever it was.
That's half.
That's only if you have the half-life.
Oh.
There's a very specific formula. So those are for half-life. It's ln2 over r, it's half-life. Which is not a half-life, because 3 is not half of 10. So p prime is equal to ln 3 over 10 over 3 times p. That's
And
your
it would
answer.
be positive because the negative Is
Yeah,
there a
because the
negative
negative.
there?
But this is a negative number. ln of 3 over 10 is actually a negative number, so the negative sign is hidden. That was part A. And then part B says find P of t and simplify. Well, we pretty much was working with P of t here, so that's just plugging it in. So part B is just to say P is equal to 10 e to, now I know what my r is, ln 3 over 10 over 3 times t. I leave it there. You could simplify by rewriting this, but I don't care.
It's not negative.
Because ln 3 to the 3 over 10 is negative.
Yeah. Yeah, your r is already has this negative sign here, so when I plug it in, it kills it.
Well,
See, I always picture the graph of like ln was at like 3 over 10. I know that it's less than 1, so it corresponds to like a negative y value.
Yeah, that's.
so if I do put a negative.
So your ln is here, this is at 1. So once you're lower than 1, like you're at 3 over 10, you are already given negative value.
Yeah, that's
So if you
how
put a negative sign here, you make it positive, and so your exponential is growing, not
How many
decreasing.
points is that? Is that
I probably take off 1 point.
it's all on video too.
Yeah, yo,
Don't plan on getting things wrong. Get everything right. You don't have to worry about it.
I'm getting everything right. Just do the right thing. No, I can't stretch you. Just do the right thing.
Okay, so now we're at problem 5, the last in the compulsory section. State the limit definition to find f prime and use it to find the derivative at 3 for this function. So basically just write this down. You remember that guy? It's been a while. And so now I'm going to use it on the function minus 2 over x minus 1. So this means f prime of x is equal to the limit as h goes to 0, minus 2 over x plus h minus 1, minus 2 over x minus 1, which makes this a plus, all over h. And that's a complex fraction, so I'm just going to multiply top and bottom by the LCD to simplify it. So I'm going to multiply by x plus h minus 1 times x minus 1 on the top and the bottom. Yeah, whenever you have fractions inside of fractions, that's what you're going to do. Look at all the denominators, take their product, you make an LCD, and multiply. Keep writing this until you actually plug in h equals 0. You can't plug it in yet, so I'm going to keep writing this. So now when you take this guy and you multiply by this term cancels that term, and you're just left with 2 times x minus 1. Plus, you take this times that, the x minus 1's cancel, and I'm just left with 2 times x plus h minus 1. At the bottom I just have h times x plus h minus 1. Don't be like Nikolai and multiply this out, keep things back.
You know if you watch a video, right?
Yeah, I know. I'm talking to him because he's not here. Don't multiply this out, Nikolai. You never want to multiply fractions, especially a denominator. You never want to multiply a denominator. Always keep it factored. Because that's how you're going to simplify, by canceling things. You want to keep it factored. Colin tried to multiply up the 9th power in one decimal. It's like, why are you doing it? It's like, oh! You know, when he has an epiphany, everyone knows. Okay, alright, so here, just expand these brackets here. So, nothing, just distributive ones here. So here I have minus 2x plus 2 plus 2x plus 2h minus 2. So minus 2x and plus 2x minus 2, this dies. And then I just have 2h on the bottom, which the h is going to cancel with that h. And so I just have 2 over x plus h minus 1. And now I can plug in h equals 0. this means, so in this problem I actually defined f prime at 3, you just plug in 3 for x. So f prime at 3 is equal to 2 over 3 minus 1 squared. That's 2 over 2 squared. So half. So that's the answer to part A. That's what they asked for. And so in part B, now you're going to find the tangent line. And at this point, you just have to remember for tangent line, this is your m for the tangent line. M for tangent line at x equals 3. So it says use part A to find the tangent line to y equals f of x at the point where x equals 3. So I know that my x1 equals 3. I have to find the y1, which is just plugging it into the x value. So it's 2 over 3 minus 1 equals minus 2 over x minus 1. So minus. And so now I just use y minus y1 equals m x minus x1. So y plus 1 equals n x minus x1. That's your answer.
So you wouldn't care what form you put it in, right?
No. Like, it never stated a specific form, so whatever. When you get there, you can stop. And now we're in part 2.
Yeah, that's correct.
So in part 2, you have to choose 4 problems out of 6, so you get to skip any 2 of them. Of course, I'm just going to do all of them. You can decide which one you skip if you're in the test.
Now let's get the curves. So, after that,
You say you're not skipping.
Yeah, you can skip whatever you want. Curve sketching is an optional.
you got the triangles already? All right, let the
What?
got the triangles, the rectangles, the area drill, the movement, whatever. That was my question. I like it.
The which one?
What is it called? Yeah, the who sounds or whatever. Doing the R or something.
Oh, Riemann sums?
Yeah, my God.
Yeah, it's here. Yeah.
I think that should be curve sketching.
20
that
questions.
That should be the whole.
Yeah, Riemann sums. Yeah.
Yeah, it's here. That should be the final.
It's here.
This curve sketching. Yeah. You old gays.
Yeah.
Isn't that what you want as a teacher? You want your students to do well?
Yes, I do.
I think you rewrite the final. I think I should write it for you.
Right, it's all the same question.
Graph x squared plus.
This one's gonna take a little while. Let's just clear this up.
Curve sketching x squared plus 1.
Yeah. So, and I'm gonna give you guys the derivatives because I already tested you on a bunch of derivatives already. So
And you know
at this
what we
point,
do with that, yeah.
at this point, I should know that. Yeah, they can definitely find the derivative. I don't want you to waste time.
But if you can't, you can still get some points.
Yeah. At this point, I just wanted you to know how to use the derivative.
Okay, so question, what if like we don't do well on the first part and we do all the like second part? Can we get points for that?
Well, it's a 60-40 split. So the first part is like 60 points, and the second part is 40 points.
Dangerous. The other part is like more.
So even if we do 5, that fifth one is not gonna count.
No, I'll grade the best ones. I'll grade the best 4.
I think you should just do all the questions.
You could. I'll grade the best 4.
So it's
Only 4 will count, but yeah, if you do all of them, that's fine.
so attempt everything. I'm getting part of credit for everything.
You see, like this mock doesn't seem that bad.
Do what?
Like this mock, this final, really didn't seem that bad.
Yeah, because when you're seeing it again, it's like
The 2009 finals OB is crazy easy. I think you should give us that.
seems fine.
That's what
Okay, so there's
Sorry,
our.
one.
So here they ask for everything: domain, intercepts, asymptotes, extremes. So let's just jump into it. So domain, of course, this is you can't be plus or minus 1. So it's either minus infinity to minus 1, minus 1 to 1, intercepts. Let's start with x-intercept. Means you set y equals 0. That just means x equals 0. Alright, so remember when a fraction is 0, the top is 0. So you just ignore the top. Y-intercept is when you plug in x equals 0, so your y is equal to 0 over 1 minus 0 squared, which is again 0. Which of course, if your x is 0, your y must be 0 as well. Because that only happens at the origin. Those are intercepts. Next thing you want are asymptotes. Let's do the horizontal. Yeah, so now remember I told you in practice you really want to do it both sides, but for rational functions, you'll always actually get the same number if one exists. There can only be one. So you can do like limit as x approaches infinity. Well, whether you do plus or minus here, you're going to get the same thing. Because it's going to be 0 because the bottom power is highest, right? When bottom heavy goes to 0, if it's top heavy, it goes to infinity, and so you have no horizontal asymptote. And if the powers are the same, you just take the ratio of the coefficients. So that's the thing.
Would you ever have like an absolute value in one of these
No,
questions?
it's going to be something like that.
Okay. I was gonna say, because if it was an absolute value, wouldn't the limit be undefined? Or it does not exist?
No, depends on if you're going to positive infinity, then you assume all x's are positive.
Mhm.
If you go to negative infinity, I have to replace all x's with minus x's, and then take the limit of that. For vertical asymptote, you just set the denominator equal to 0. So now x equals 1, or x equals minus 1. These are your vertical asymptotes. Here, y equals 0 is your horizontal asymptote.
So which one is you can't cross?
You cannot cross these. Because these happen when the denominator is 0. So that means you divide by 0. You can't do that. This one you can't cross. Okay, let's do increasing, decreasing, max. So curve sketching, it's long, but I feel like the process is easy. So I probably, if you do 4 other ones and you want to just do a 5th one to see if you get most points, I'd probably do curve sketching. It's going to take a lot of time, so you probably want to leave this for last if you're going to attempt it. It's pretty much going to be the longest problem you find. So yeah, increasing, so remember we're going to find the first derivative. So find the critical points in f prime equals 0. So f prime is this guy, so I have x squared plus 1 over 1 minus x squared equals 0. Notice that there are no solutions.
So I have a question. Whenever like I get to like a question like that where it's like where prime is 0 or it's undefined, how do you know which one you would pick?
You always check for both. You check for both, right? So here I say equals 0, it happens to have no solution. Then check for undefined. Then it's, of course, x equals plus or minus 1. So those are my only critical points here.
Okay.
You always check for both. You always have to do both.
Wait, why is it no solution for?
A fraction is 0 if the top is 0. X squared plus 1 is never 0. Right, because your x would have to be the radical of minus 1, which is complex, and we don't do it. So now you test points like a minus 2, or 0, or 2. You test it in the first derivative. So you're going to go here. Notice that the denominator is squared, but notice here, this is really nice. The denominator is a square, so that's always positive. And x squared plus 1 is also always positive. It's literally always positive. It's always increasing. Because these are all squares. No matter what numbers I'm plugging in, as long as they're not 0, it's going to give me positive. So that's always increasing. So there's no max, no min. And interval of increase is minus infinity to minus 1, minus 1. You still have to tiptoe around where you're not continuous. And decreasing, never. Now we go over here to find concavity and inflection points if there are any. So here we're going to look at the second derivative, 0 or undefined. Notice that for it to be 0, it's a fraction, so the top has to be 0. So I need 2x over x squared plus 3 equals 0, which means that x equals 0 is the only solution to that. And for undefined, again, x equals plus or minus 1, that's where the denominator is 0. So here there are 3 points to test, and I'm testing them in the second derivative. It's a 0, a 1, and a minus 1. So plug in like a minus 2, a minus a half, positive a half, and a positive 2. So now these powers are odd, so this one is going to take a little bit of work. So if I plug in a negative 2 here, that's going to be a negative. This part here is always going to be a positive. Over, plug in a minus 2 here, I get 1 minus 4, that's a negative. So here it's a plus, which means concave up, like a cup. Plug in a half, this is going to be minus a half, this is going to be negative times a positive. Over 1 minus a quarter, that's going to be a positive. It's negative, concave down like a frown. Here, it's going to be a positive times a positive, for a positive, concave up like a cup. Over here, it's going to be a positive, positive. Over, plug in a 2 here, that's 1 minus 4, that's going to be a negative. So negative, concave, down like a frown.
So I'm gonna say, it's not an equal line, but would it be safe to assume that since negative 1 and 1 were in the domain, like it can't be?
They're not in the domain.
Yeah, those aren't
So
inflections.
they're nothing, they're not inflections. Zero
would
is.
be. Okay.
So 0 is going to be an inflection. Because these two actually don't exist on the graph. They're actually vertical asymptotes.
Got it.
So they're nothing. 0 is an inflection though. So we have the following. We are concave up on negative infinity to minus 1 and 0 to 1. We are concave down on minus 1 to 0, 1 to infinity, and we have an inflection at 0, 0. Right now, my x value is 0, my y value is also 0. And now we can draw the graph. So remember, the first thing you put in is are your intercepts and asymptotes, and the main points, the coordinates. So let's do minus 1 plus 1. Horizontal asymptote is right on the axis, you just do it. We know we have an intercept right at the origin, so I'll put that in here. That's also an inflection point. We don't have any maximum or minimum points to plot. So that's that. And now we put in these guys. So we know we're increasing pretty much everywhere. So here I'm increasing. Here I'm increasing. Here I'm increasing. Concave up. Here. Concave down here. Concave up here. And concave down here. So how does this look? So I'm increasing concave up. So I'm increasing but face up like a cup, right? Now the question is, where am I?
Above.
I have to be above, because if I was below, I'd have to cross, which makes an x-intercept, which I know shouldn't be there, so I have to be above. Here, I know that's an x-intercept, and since I'm increasing, I have to come from down here, concave down, so I'm shaped like a frown while hitting that point. So I come like this. But it's an inflection, I switch the concave up, and I continue to increase, so it switches to that. Here I'm increasing concave down. So I'm going up but I shape like a frown.
You're below the axis.
You have to be below, and then stay below. And that's your graph. Okay, so now we're on problem 7. Starts with our related rates. This is one with a curve. I think on the final I'll probably put one of those fence ones or the box ones. Here's a box and the sides cost this. You know, one of those fence ones. But for this one, you're just given the relationship. You know that y squared plus xy equals 2. That's you have a particle traveling along that curve. As it passes through the point 1, 1, the x coordinate decreases at a rate of 3 units per second. Find the rate at which the y coordinate is changing at this moment. So this is our relationship, which would be like step 3 in an optimization problem. But now we're in a related rates problem. So now we're going to actually find the derivatives. 2y dy dt, differentiate with respect to t. Here, you need the product rule. So you differentiate the x, which is dx dt, leave the y alone, plus leave the x, differentiate the y. Derivative of 2 is 0. And now we plug in what we know. Right? So we know we're passing to the point 1, 1, so our x is 1 and our y is 1. We also know that the x coordinate is decreasing at a rate of 3, which means dx dt is a minus 3. The sign matters there. So them telling you decreasing actually matters. So it's 1 dy dt we don't know, plus dx dt is at minus 3. This is because it's decreasing. Y is a 1, x is a 1, dy dt I don't know. So I end up with 2 dy dt minus 3 plus dy dt equals 0. So 2 dy dt plus dy dt gives me 3 dy dt. And this minus 3, I'm going to go over here, I get 3. Then divide both sides by 3. So you get dy dt equals 1. Or you could say it's increasing at a rate of 1 unit per second.
And you can, what I didn't substitute at that point. I moved everything to one side and then substituted.
That's fine.
Wait, what happened to the 2?
What 2?
The 2 in front of the y.
Oh, it's here. 2, the 2 is here, but I combine these. I have 2 dy dt plus 1 dy dt.
Oh,
So I have 3 dy dt's. 2 apples plus 1 apples. Who was the first person to use apple? It's always apples. Apples and oranges. What? See, these are the hard questions. These are the questions you need to answer. Why apples and oranges? Why could it be cantaloupes and pine? Well, they can be cantaloupes. More often than I'd like to admit. It's like, why would you use a cantaloupe? Yeah, and why would you buy 2 of these things? Like, Tom, buy 200 cantaloupes at Stop and Shop.
He's broke.
No, he can't afford his rent.
He's on the street.
Okay, limits. So I can't plug in x equals 1 because I divide by 0. What do you think I need to do?
Factor or break it up.
Okay.
Expand, you'd have x plus 1, x minus 1 on top.
Sure, yep. And bottom?
And then on the bottom, you'd have
X squared minus 1 x squared plus 2 plus 1.
Other way, 1 minus x squared,
Yeah.
1 plus x squared. Which this you could have noticed would have cancelled with that. So you didn't even have to factor that part.
oh no.
But if you wanted to go there. So here you're going to realize that you actually didn't have to factor that, because this guy here is just the negative of that. So this goes into that -1 times. So it's just -1 over 1 plus x squared. And now you can plug in x equals 1. And so happens. And here, the limit is like goes to minus infinity. 3 minus 5 plus 12 over 12.
Question on the previous one. Wouldn't it be possible, because I wrote the bottom fraction as x squared minus 1 and then x squared plus 1.
Yeah, that's actually wrong.
That's wrong.
Yeah.
Gotcha.
It has to
Oh,
be,
yeah, I
the
see.
difference of squares is a minus b times a plus b. So the 1 should be in the first position.
Gotcha.
Who has the negative fraction?
Isn't it -5?
No, at this point, hopefully you remember that pi is actually smaller than 12.
Yeah.
What? Yeah. Right, so 12 here is actually the biggest power on the top. And 12 is the biggest power on the bottom. When you ever see these guys, you only care about the biggest power. Ignore everyone else, they don't matter. Right? And so once they are the same, you go to the ratio of the coefficients. So this just becomes 5 over minus 1, or minus 5. Right, yeah, now this is the one I was talking about, 8A. Yeah, like at this point, I probably asked about the cost of some blocks or something. Material for a fence, you know, this side of the fence is concrete and it costs this much per foot. This one was sort of like the cruise question. So 8A. An artist is planning to sell signed prints of her latest work. If 50 copies are offered, she can charge $400 each. But if she makes more than 50, she must lower the price of all prints by $5 for each print in excess of 50. How many prints should she make to maximize her revenue? So here I would say let X be the number in excess of 50.
So would you set your objective to be 400 minus?
I.e., hold on. The number she sells or prints is therefore 50 plus X, right? Right, it's going to be that base 50 that she's selling plus X in addition, right? So if we look at her revenue, she is selling 50 plus X items, and at what price?
400 each.
She's selling at 400 each, except she's lowering the price by $5 each for each in excess of 50. So what does that do? Minus 5X, right? So for each of the X things above 50, she subtracts $5 from that cost. So that's how much money she's making. This is number she sells, and this is the price with the discount. Right, so her base price was 400, but if your X is anything above 0, she's subtracting $5 for each X. So that's your revenue. And so now you just want to maximize that. And that's going to tell you how much she needs to just make. So if her promotion is to, oh, I'm going to reduce by $5 for everyone I sell over 50. Then she knows she's only going to print this much and then tell everyone else, yeah, we're out. because she's not going to make any more money by selling any more. So we want to figure out what that sweet spot is. So you could multiply out. You could also use the product rule. Derivative of this is 1 times that minus plus. Leave this and differentiate this, which is a minus 5. And of course, for max, we set r prime equals 0. So this means we have 400 minus 5x minus 250 minus 5x equals 0. This means these, bring them over here, so I have 10 over here, and 250, this gives us 150. So this means x equals 50. This means she should print 75. That's 65.
So you just plug back 15 into revenue?
Yeah, 50 plus x. Right, this is your 50 plus x. Yeah. How many prints should she make? Right? So she should make 65. That's the most amount of money, right? She would make. So if she prints more than that, she's actually losing money at some point. Her discount is too steep for her to make money. So yeah, with that promotion, she should print 65 and don't sell any more. So with 65 prints, she'll make the most money. E, inventory cost. And here it just asks you to set it up. You don't have to actually be minimizing it, right? So here it says find the cost function. It never said find how many x's you need to minimize, right? So read the problem carefully. So this is just a setup. This is inventory cost. Once you see inventory cost is even in the name, you actually know the formula for it. So we know that it's the order cost times total number over x plus storage cost times x over 2. Order costs. It says ordering parts to make X new chairs costing $55 per delivery, so that's 55. The first sentence says he sells 3,000 chairs per year, that's the total number, so it's 3,000 divided by X, plus the storage cost, costing $2 per year to store each chair, that's 2, times X over 2. And that's basically it. Nine. Geez, this one is too easy. We're almost done. It's barely over an hour.
Dude, I was doing it.
This thing is supposed to be like a 2-hour exam. 2 hour, 15 minutes.
You gotta check hours for the extra hours.
Yeah. Do it twice. Just fly through and do it twice and then just compare it. I need an extra copy, Javon. I want to do it again. Reminds me of the old days. When I was doing chemistry, I used to do all the tests like 2 or 3 times. Because back when I was a kid, I was OCD. I was like, I have to get an A, I have to get an A. I used to just sit and do exams over and over because I'd always finish it. Well, it's something like chemistry anyway. Chemistry wasn't so bad. Use Riemann sums with 4 subintervals and right-hand endpoints. Estimate the area under y equals x squared between x is 0 to 1. Right, so y equals x squared is what I'm estimating on the interval 0 to 1. So that's my A, that's my B. And for n equals 4, I want 5. So basically, I have my interval, and it's going from 0 to 1. So I'm going to set delta x is equal to b minus a over n, which is going to be 1 minus 0 over 4. So it's a quarter, or 0.25. So then I divide this into each section is a quarter. So it's 1 over 4, 2 over 4, which is a half, 3 over 4, 4 over 4. And I want right hand endpoint, so I know the 0 is on the left, so it's going to be this guy, this guy, this guy, and that guy. And I'm just going to plug that into the given function and add them together. This means that my area is approximately equal to R4, which would be equal to delta x times f of a quarter plus f of half plus f of 3/4 plus f of 1. And I'll add an instruction here that says it's okay to leave your answer as a sum of fractions, because I don't. So delta x would be a quarter. This guy would just be a quarter squared plus, I'm plugging into this function x squared. A half squared plus 3/4 squared plus 1 squared. That's fine. That C should be B. So yeah, in part B, find the exact area. How are we going to do that? Well, it tells it, use integration. What integral?
0 to 1.
Yeah, just the antiderivative from 0 to 1 off the function x squared.
Yeah.
And so that'd be x cubed over 3 between 0 and 1. Plug a 1 in. Minus plug a 0 in. So the actual answer should be a third. I don't know how close that is. That's going to be an overestimate,
And
which I didn't ask you that here.
I think it should.
No,
But I'm curious, how would you know?
because I know y equals x squared. It's like this.
Oh, like that.
And I'm on the right side, so it's going to always be above when I'm on the right side.
Oh, without drawing it, you know, because like.
No, that's what I picture in my head.
Oh, okay.
To figure it out without drawing it, I'd actually have to know what this is and compare it to a third. But no, I pictured it in my head. So the right side.
With 9, you have to calculate it, right? You know, you can't just leave it like that.
No, that's fine.
Oh, that's fine. Okay.
It's problem 9. I'm gonna have to do 4, so we're gonna stop now. We have 2 more problems left. So 10. Okay, an object is launched from a height of 256 feet with the velocity function vol after t seconds. Find the position function. So the trick here is to remember that your position is just the antiderivative of velocity. So basically what you need to remember here S is position, E of t is velocity, A of t is acceleration. Then to move down in this list, you differentiate. And to move up in this list, you integrate. Alright, so if I have position, differentiate it once, I get velocity. Differentiate that once, I get acceleration. And to go the opposite, you anti-differentiate. So to go from acceleration to velocity, I integrate. Integrate that, I get to position. So here they gave me velocity, and they asked me for position. So what I'm going to do is I'm going to integrate. And they told me that the velocity function was minus 32t plus 96. And that's just power law. So that's going to be minus 32t squared over 2 plus 96t plus c. This goes into that. This minus 16t squared plus 96t plus c. That c, though, we have to find. That's an arbitrary constant. We can find it though, because they actually told us the initial height. An object is launched from a height of 256 feet. So we know that when t equals 0 in the beginning, my position is actually 256.
That's our constant.
So that's going to be our constant. So I know that this means 256 is equal to minus 16 times 0 squared plus 96 times 0 plus c. So I get that my c is 256, which means ultimately that my s of t is minus 16t squared plus 96t plus 256.
It's not minus 250.
No, plus. They told us the height.
So how did you get 256?
But even so.
They told you.
in your
It says the object is launched from a height of 256, so that's in the beginning. It's at 256, and they launch it with this velocity. So 256 is what the position was when time was 0. Right, something else they could say is an object is launched from the ground, at which point you assume position is 0. The ground is always level 0. That's part A. B, when will the object hit the ground? Hit ground when s equals 0. Just like I said, ground is always position 0. So when they talk about hitting the ground, they're talking about position 0. So all I'm going to do is set the position equal to 0 and solve for time. $16 goes into all of these guys, right?
That's
Yeah, that goes 6 times, yes. How many times does it go into 256?
No.
13,
no, I don't know.
maybe 16?
16.
16 probably.
Real close.
Right? It's definitely higher than 10, because that would give us 160. So now I'm going to think of a number that when I multiply it by 6, I get 6 at the end. 6 is 36, so I'm thinking maybe 16. And I'd probably double check over here. 6 is 36, 6 is 9, 0, 6, 1, 6, 5, 2. Yeah, so 16. Let's hope this foils so I don't have to do something crazy like quadratic formula. 16, 8 times 2. That seems to make sense. You get a minus 8 on
Plus 8.
How would that work?
That's
Oh no. Minus 8 plus 2.
oh, sorry, this is a minus. Because I factor out a negative. So minus 8 plus 3 does work. Yes. So this means that my t is 8, or t equals minus 2, which of course you reject. This is in quantum physics. So it hits ground after 8 seconds later. How high will the object get? We want max height. Right? This means maximize s. This means s prime equals 0 or undefined, which means we set velocity equal to 0. Which in physical interpretation you can see that when you go up, you have to stop and then you start going down. Right? That instant where you stopped, where your velocity is 0, that's where your max height. Our velocity function was minus 32t plus 96. Set that equal to 0. You get t is equal to 96 over 32. And 16 went into both of them. That was 16 into 6, 96 goes 6 times, 16 to this goes 2, so that's 3. So 3 seconds for max height. Oh, they didn't ask me how long, they said what is the max height? So we're not done. I have to go back to position. I have to tell them the position. So that is max height equals S of 3. And plug in 3 into my S function. Three into 96 goes 332. So that's 32 times 9. So 16 nines plus 32 nines is 16 nines. Plus 256 plus 16 16s. So that gives me 25 16s.
Can I leave my answer on the top? Can I leave my answer in that top one before you started using magic?
Just stop it. Or you can just multiply it and just add them. Okay, so here roughly sketch the curve blah 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 on the same pair of axes, find the area in between the curves. So here they specifically ask you to sketch it. So let's call that curve 1. Minus x squared plus 6x minus 5. Curve 2. 2x minus 5. To start with this one, if I factor out a negative, hopefully this spoils 5 and 1, maybe. So the minus and minus.
Yeah.
Right. So that gives me the intercepts, right? That's x equals 5 and x equals 1. So then I know that that's an upside down parabola that goes through 5 and 1. So that's where do these intersect? Minus x squared plus 6x minus 5 equals 2x minus 5. 2x squared minus 4x equals 0. So x equals 0, x equals 4. So they intersect here, and they intersect at 4. So that's our picture. That's the region of parallel.
And that point is -5, right? Down there, to 0.
Right here, yes, it's -5, because you look at the x-intercept for either. So you plug in x equals 0, you get -5. And here, if you plug in x equals 0, you also get -5. So they have a common point of -5. And they intersect at 4. So that's the sketch. How do we find the area between them? Area equals the integral of top minus bottom. So then the integral goes from 0 to 4. Right, it's the end of the shaded region that we care about. So from 0 to 4, and who's on top? The problem, right? So I'm going to put minus x squared plus 6x minus 5 minus the line 2x minus 5. Minus x squared plus 6x minus 5 minus 2x plus 5. Just die. Plus minus x squared plus 6x minus 2x. Which just makes it 4x. At that point now it's just power rule, so it's x cubed over 3 plus 2x squared to 0 to 4. From a theorem, take the 4, you plug it in. Minus take 0, you plug it in, therefore it's 0. So 4 cubed is now. Huh? Minus 64 over 3 plus 16 times 2 is 32. So it's minus 64 over 3 plus 96 over 3. That gives you what? 12? What does that do?
How did you get that y-intercept, the -5?
Oh, plug in x equals 0 for the y-intercept. So I plug in 0 here, I get minus 5. Plug in 0 here, I get minus 5. They both fit that y-intercept. So these here were the x-intercepts.
Okay.
For y-intercept, we set x equals 0. So you get y equals 0 plus 0 minus 5.
And why did you only choose to use that one? Because it's the parabola? Or?
In this case, it didn't matter because I know they intersect on the y-axis. One of the intersection points was x equals 0, so it really didn't matter who I picked. That's it. You guys gonna get A's tomorrow?
Yes.
Good. That makes it easier on me. Just one big curve sketching. Curve sketching and Riemann sum is
That's everything. That's everything. Area, you know. Derivatives. Come on, man.
There's everything in there. So we're gonna be here tomorrow at the regular time, 6, right?
6.
6. Yep.
We can still email you if we have questions. And we will be here for the tutoring session.
Yeah, I'll be here in 2 weeks. 12 to 5. Okay, that's it. I'll see you guys tomorrow.
How quick is this video going on?
I don't know when I get home.
I thought you would.